Hello. The product rule allows us to take the derivative of a function that is a product of two other functions. So if the functions are f of x and g of x, then the derivative of the product of f of x and g of x equals the derivative of f of x times g of x plus f of x times the derivative of g of x. And in a more compact way, that is d dx of f times g equals f prime g plus f g prime. Now let's see three examples. In the first one, we will find the derivative of y equals x cubed times e to the x power. First, notice that in this function, we have a product of x cubed and e to the x power. So then, to find the derivative, we will use the product rule. In this product, let x cubed be represented by f and e to the x power by g. And now let's see how we can find y prime. According to the product rule, first we have to take the derivative of f and multiply it by g plus f times the derivative of g. In our example, to take the derivative of x cubed, we need to apply the power rule. According to the power rule, we will move the exponent 3 in front and we will decrease the exponent by 1. Then we will have 3x squared times e to the x plus, then here we will bring down the f function, which is x cubed, and we will multiply it by the derivative of the g function. And the derivative of e to the x is still e to the x. So we will have x cubed multiplied by e to the x. So we found the derivative using the product rule, and if needed, we can factor out x squared and e to the x power. Then we will have y prime equals x squared e to the x power times 3 plus x. And now the first example is completed. In the second example, we will find the derivative of y equals cosine of x times cube root of x. Here we have another product, so again we will use the product rule. Also, notice that this function has a radical, and before starting the derivative, it would be easier if we write it in exponential form. So I will rewrite this function as y equals cosine of x times x to the 1/3. Then in this product, let cosine of x be the f function and x to the 1/3 the g function. And now to apply the product rule, we will also need the power rule and the derivative of the cosine function. So then y prime equals, and first we will need f prime g, and the derivative of cosine is negative sine. So we will write negative sine of x times x to the 1/3 plus, and now we need f g prime. So we will bring down cosine of x and take the derivative of x to the 1/3. According to the power rule, we will move the exponent in front and decrease the exponent by 1. So 1/3 minus 1. Then y prime equals negative sine of x times x to the 1/3 plus cosine of x times 1/3 x to the negative 2/3. And now here I will write cosine of x in the numerator, and I will bring x down to the denominator and make this exponent positive. So then y prime equals negative sine of x times x to the 1/3 plus cosine of x over 3 x to the 2/3. And now we can also write each of these expressions in radical form. Then we will have y prime equals negative sine of x times cube root of x plus cosine of x over 3 times cube root of x squared. In the third example, we will find the derivative of 4x squared plus 5 times tangent of x. And again, because we have a product, we will use the product rule. And besides the product rule, we will also use the power rule and the derivative of tangent of x. So then, let 4x squared plus 5 be the f function and tangent of x the g function. Then y prime equals, and now first we need the derivative of f, and the derivative of 4x squared is 8x, and that is because when we move the exponent in front, we multiply it by 4 and we get 8. Then we decrease the exponent by 1. So we will write 8x, and the derivative of 5 is 0 because the derivative of a constant is 0. And now we will multiply this by the g function, which is tangent of x plus, and now we need fg prime. So we will bring down the f function, which is 4x squared plus 5, and take the derivative of the g function. And the derivative of tangent of x is secant squared of x. So now we will multiply by secant squared of x. And now the problem is completed. Thank you for watching.